Welcome and hello. This is a video exercise using HEC HMS. And in this exercise, we're going to be dealing with importing and using PRISM gridded data. All right, in this exercise, we will find, download, import, and use PRISM gridded precipitation data in an HMS model. PRISM, P-R-I-S-M, is an acronym, as you see on the screen here, for the parameter elevation regressions on independent slopes model. The purpose of this tutorial is to show how to import PRISM data and also to demonstrate how alternative precipitation data sources can lead to different results between hourly NextRad data, which is already going to be in the model, plus the PRISM daily precipitation data, which we're going to retrieve ourselves. All right, so the page that you're seeing here on the screen is it's the first link in the description of this video, so you can go ahead and follow along if you like. Before we want to get started, we're going to want to go ahead and download the files here. There's 3 links here. The first one is the HMS project. The second one is a sub-basin outline for clipping data source. And then the third one here is PRISM files. As you see, I'm just having these downloaded onto my desktop. Once those are downloaded, just go ahead and put them in a place where you want to keep them for a while. For me, I'm just going to put them in this directory here. Here is the HMS project. So it looks good. I'm just going to drag that over. It should unzip on its own. Then I can delete that. For these 2 other directories, I'm just going to drag them into the this folder here, and then unzip them in place. So right click and then extract all. Extract. Same thing with this ASCII data. Extract. Extract. Delete the zip file. All right, let's go ahead and open up that project in HMS. I'm going to open and then browse and go to the exercises project. Here it is, Canon Rev. And then here's the .hms file. So I'll click select and then convert project. All right, let me go ahead and open up that basin model. Here it is. So when I bring in the PRISM data, I'm going to need to crop it down to the specific watershed. So what I'm going to do here, instead of using the shapefile provided on that download link, I'm going to go ahead and just go GIS, export layers, subbasins, and then next. Then I'm going to navigate to where I want to put this in projects. Okay, so here's my project. I'm going to put this in my GIS directory. And then I'm just going to call this shapefile watershed boundary and click save. Okay, and then finish, and then okay. I'm going to confirm that it was there. And here's the GIS. All right, there's my shapefile. Looks good. I'm also curious where in the world this watershed is. I know it's in southeast Minnesota, but it's easier to just see on a map. What I'm also going to do is add in a shapefile for the shape outlines of the United States, as I have saved in here. All right, that has been added in. So we're dealing with southeast Minnesota. So this is a fairly large watershed. And I can also tell it's a certain distance from the Iowa border and Wisconsin border. I bring this up because I'm interested in being able to delineate the watershed myself, not just always download the same file from the exercise, because in real life, we're going to have to do this. So let's go ahead and take the first steps. Let's open up a browser and then open up a new tab, and then go ahead and use the link in the description, the second link. That will take you to this page here, the USGS website for downloading elevation maps, among other things. And let's start to zoom in on Minnesota here. We know that this river is called the Cannon River, and I think this is it right here. Yep, Cannon River. There's other ways to find it, but here it is. And then this is where it enters the Mississippi River. So what I'm going to do here in this map is zoom out a little bit and then click on elevation products. And then I'm going to select the 1 arcsecond DEM current and then unselect all the other checkboxes. Okay, that looks good there. So once I have my map centered, I'm going to scroll up to the top and then click on search products. And it should bring up a number of files for elevation data for me to download. 20, I think, is too many, because if I hover over that tile, it should show up on the map as to where it is. And none of these are very close. Okay, so this one's pretty close. So 93 west, 94 west, and 95 west. That should probably be good. So I'm going to download 93 through 95, 44 north, as well as 45 north. Okay, so let's go ahead and click the download link. So it's downloading right there. That's 93. 94, 95. Okay, then at 45 north, this is 93. Download that one. 94 and 95. So I've got my 6 TIFF files over here. I'm going to move these into my GIS directory, which is right here with the shapefile. I'm just going to drag those in there. Next, I'm going to open up QGIS to merge them all together. There's multiple ways to do that, but QGIS is one of the faster ways to perform this task that I'm aware of. So here's my new session of QGIS. I'm going to take my TIFF files here. I think I can just drag them over into the main panel for them to appear. Then I'll have to click OK to accept the projection. All right, here are my layers. Over in my layers panel, I'm just going to collapse these so they're easy to see. And right here, I have the Cannon River. So it's flowing north and then east, and then it has its confluence with the Mississippi River. I would like to import all these map layers as a single TIFF layer when I go over to HMS. So what I'm going to do is merge these 6 TIFF files together. So I'm going to go up to raster and then miscellaneous and then merge. Now I have to select the layers here that I want to merge. So I'll click on this little ellipse icon and I want to merge all these. So I'll just say select all, and that's all I have to do there. So I'll click run. It should give me a new layer. Okay, so it says merge right here. Looks like that's done. So you can see this is the merge layer. And then if I toggle that off, these are the 6 individual layers before they were merged. Now I want to export this TIFF file so we can later import it into HMS. On this merge layer, I'm going to go right click and then export, save as. Okay, here's the save as. I'll save it as a TIFF. I'll click the ellipse tool here, and I want to save it to my GIS folder again within my HMS project. Here's the project, and here's the GIS folder. Okay, so I'll just say, call it dem.tiff and save. During the import process, we also want to have a buffer clip, and we downloaded a clip file, but I also want to demonstrate how to create your own polygon shapefile in QGIS. So what I'm going to do is I'm going to open up the subbasin shapefile that we exported from HMS, make it show up on this map here, which will probably be right in here, and then we'll go ahead and create our new polygon shapefile. So to do that, I'll go up to layer, add layer. This is going to be a vector. So I'll click the ellipse tool. I'm going to change these to a detail display. And here we have our watershed boundary. It's a watershed boundary shapefile. That's what we want. Okay, so I'll click add, close that. Here is the watershed. So it looks like we got the correct TIFF file and elevation location. So what I'm going to do now is go up to layer, create layer. This will be new shapefile. I'm going to navigate to that same GIS directory. Here's the GIS directory here. Here's the original watershed boundary. I'm going to name this watershed boundary plus buffer and then click save. Okay, the other thing I need to do here is say the type is going to be a polygon and then OK. All right, so I'm ready to start editing. Over in the layers map, I have my, my new layer here. So with that selected, I'll go ahead and click the edit tool, and then I'll start adding a polygon. So I'm just sketching out a polygon here. Okay, and then I'll right click to complete and then give it an ID. Just call it 1 and OK. There is my new shapefile. So I can just put that beneath the actual subbasins so we can confirm that we got the entire area. I also want to confirm that that was saved over in my GIS directory here within the HMS project, and there it is. One last thing I want to do in QGIS here is to actually clip out the DEM that we're seeing here into just the area of the subbasin. Because this is a huge file and it could take a long time to actually do all the GIS processing in HMS. So I'm going to go up to the raster menu and then extraction and then clip raster by mask layer. Import layer, this is going to be the TIFF file itself, the elevation layer. Okay, so I'll navigate to my GIS directory, and it's going to be this first file here, dem.tiff. And then the next, I have to select the mask layer. This is going to be the mask layer with the buffer. So that's this one right here. And I'll leave all the optional settings unselected. Okay, that looks good. What it gave me on the screen here is my clip DEM. I'll call it DEM clipped, in fact. So I'll just need to export that and then export, save as. It will be a GeoTIFF file. And then I'll navigate right here. This is where I want it. DEM TIFF is what I have. This will be DEM clip.tiff. Then I'll click save and then OK. All right, so that got saved. We can go back to HMS now and then zoom in on our area of interest. What I'm going to do is create a brand new HMS project, and then I can import that clip DEM TIFF file as a terrain data, and then that will be assigned for the basin. So here's HMS. I'll go ahead and create a new project. So go new project, call it exercise 29, then navigate to where I want to go. Project from scratch, select, and create. All right, so first things first, let's create a basin. So I'm going to go components, basin model manager, new, and then basin one. Sure, we can just call it that. Let's go ahead and open that up. Now, what I said before, we'll go ahead and add that flip DEM as a terrain data layer. We'll just call it terrain one. And then now we need to navigate to our GIS directory. Actually, it was the GIS directory of the other project. It was in here. DEM clip. Okay, I should probably save it in the same project directory, but it's all right. Finish. Now in the Watershed Explorer, here is my terrain data. Here is the basin. Let's go ahead and make that connection, that association, and then click Save. It's asking me for a coordinate system, so I'll click Select, and then Predefine. Now the coordinate system we want to use here is UTM, and that's going to be Zone 15 North. And I'll click Select, Set, and then that should come into place here. All right, perfect. So we have our DEM, and this is our river. Next, we need to use the GIS tools right up here. We have coordinate system already set, and then we have terrain reconditioning. That's optional. Next is pre-processing syncs. So let's go ahead and run that. Okay, so that looks successful. Go map layers. We have the sync locations. Next up is going to be the next GIS process. That's pre-processing drainage. Okay, this process has already taken 25 minutes, so I'm just going to cancel. And I'm not going to put up with that, but we got as far as I wanted to do with regard to finding the TIFF file, cropping it, getting it all ready to go. After that, we would just continue with these GIS tools to delineate the basin. But unfortunately, I'm going to have to revert back to our original HMS project to complete this exercise. Well, it was a worthy shot, but sometimes you have roadblocks and I don't have 10 hours to wait around. Let's just go ahead and go back to the instructions here. So what it talks about is downloading the PRISM data. That's the main impetus of this exercise anyway. The PRISM climate data group gathers climate observations from a wide range of blah, blah, blah. This link right here is the most important thing. So go ahead and open that up in a new tab. And what we have here is all sorts of data. What we need to do is click on recent years to get the data that we want for this tutorial. We're going to select precipitation. I want daily data. So click this radio button down here and then 2014. And then let's download June 1st, or the whole month of June. And then we don't want to choose a day, but on this button down here, we want to select download all data for the month. And then that should start downloading. Okay, good. And then we're going to switch to July and then click download all data for the month. I'm going to put that data inside of my data directory. I'm going to create a new directory here just to kind of keep it organized. That's going to be called PRISM precipitation data. And I know that it's for those 2 months. Okay, so I'll open up that directory. Then I'll just drag those 2 zip files in here. And then I'm going to right click, extract all, extract. Now the other one, right click, extract all, and extract. Okay, now we can delete those zip files. So we have our data right here. In fact, I'm going to move all of this data and just cut it and move it into the parent directory here. So that all both months' data are in the exact same directory. From the data we downloaded, we were given this data.asc file, and there's a lot of useful information in this PRISM format.pdf. So if I open that up, we see the PRISM gridded climate data formats. And I read this whole page. It's actually rather informative, I thought. It's talking about the format here. For instance, whenever you see a PRISM file, it's going to take on this particular pattern. That'll start with the word PRISM and then a variable here that relates to the variable in this table here. So it's highlighted PPT, which is precipitation, but the variable could also be Tmin, Tmean, Tmax for temperature. TD mean is dew point, and then this VPD refers to vapor pressure deficit, either min or max. And then there'll be an underscore in the file name, and then the next part will be stability, which refers to this line of data, and then the next separated by underscore, there's scale and version, time period, and then all format, and then the file extension. The file extension will either be bill or ASC. So I believe we got bill files for this project, but the user's manual talks about ASCII files. So either way, it works the same. They both import fine. And then here are some of the files themselves. So the .asc file, this is the main data file. We'll take a peek at some of these files. This is an XML file. Here's an info file. Here's a projection file. Then here's a CSV file. So all the data is either in the ASCII file or in the CSV file. Just as a preview, here is the ASCII file itself. So it looks like an ASCII file. Next over is the CSV file. The file contains a list of stations that provided data. So we have station data here. After that, we have all the small files with just a little bit of metadata, description. This is precipitation data. So yeah, just summary data. And then there's the projection file. So now that we got a preview of what we just downloaded, now we can return to the actual instructions using the HMS gridded data import wizard. This is where we are next. So we're going to go ahead and perform this step. Let's go back to HMS. Then we're going to go File, Import, and then Gridded Data, Importer. Now we need to select those bill files that we downloaded from PRISM. So I'll select the file selector here. Here's the project. And then I put that in Data, and then PRISM Precipitation Data. Now here are all those bill files with the data. And Open. Okay, then I'll click Next. I need to select the variable. PPT is that code for precipitation. That's good. Next. Okay, now we need to apply the cropping. This is going to be the shape file that's going to limit the amount of precipitation just over the watershed buffer. That's this right here. Next up will be our projection. We're going to use SHG. The cell size is going to be 2,000 meters per side of each cell. And then the last step here is bilinear resampling. I'll click Next. The instructions tell me to navigate to the data directory and call this shapefile PRISM ASC. Here's the data directory. And then this is where I want to save that resulting DSS file right here, PRISM ASC.dss, open. And then for the path name parts, I'm going to type in SHG for part A, canon, and then part F will be the data source, which is PRISM. Okay, so I'll go ahead and click Next, wait for that to complete, and then we can close the importer. Okay, so next on the instructions, we're down to this part here, using the gridded meteorologic data within HMS. What we want to do is actually create a gridded data set that's going to be for precipitation. So I'll click on Grid Data Manager. For precipitation grid sets, I'll click New. Then I'll give that a name. The description that they use is this right here. Now we have two precipitation grid sets. One is going to be using hourly data that's already set. And then this PRISM precipitation grid is going to be the daily data that I'm going to assign right now. Click on grid data. I'll expand my precipitation data. Click on PRISM. And now for the single DSS record, I'll click the little folder icon and navigate to that DSS file that we just created. So here is my project. Here is the data. And here it is, PRISM ASC.dss. Select. Okay, so now I just need to select all the paths. So I'll just select the first path, and then that'll register with the timestamps. And then we're good there. I'll click Select Save. The next step in the instructions is to create a meteorologic model. So Components, Meteorologic Model Manager, and then I'll just give it that name there, 2014 PRISM ASC. And then there's a description. So let's go ahead and open up that meteorologic model right here. And then the first thing I like to do is click Basins and then change this to yes, say that I am using these subbasins. I'll go back to the Meteorology Model tab and change this precipitation method from specified hydrograph to gridded precipitation. And then I also need to change this replace missing to set to default. Now, if I select gridded precipitation icon up here in the Watershed Explorer, I need to assign that PRISM grid to this MET model and save. Now we're ready to create a simulation run. So I'll go up to the compute menu, simulation run manager, new, and then I'll just call it 2014 PRISM, next. And then this is the basin model. We need to make sure to select our PRISM meteorologic model because that's going to have our daily precipitation data. Next, and then this is the control specification. All right, let's close that. The control specification shows that we're dealing with June 10th until July 20th. So about 40 days of a simulation on a 1-hour time step. That means our daily precipitation data coming in from PRISM will be converted to a 1-hour time step, which will affect the results, which we'll see in just a moment. So let's go ahead and run those two simulations. First, the PRISM run, and then the other simulation will run right here. It's called calibration, but I like to call it next rad, and it's going to be the hourly data. Okay, that completed. Let's look at some results. I'm going to scroll up here to the outlet of the entire subbasin, and then go right-click, View Results Graph. Now this is the graph for the calibration run or the hourly data. We see a peak discharge at this outlet on June 21st. It's around 12,000 CFS. Let me look at the same data point, but for the PRISM simulation. We'll go right-click, View Results Graph. And now we have, it's the same time to peak approximately. However, the peak flow rate is much less. It's less than 8,000 CFS. The tutorials and guide page tells us to compare the flows and data at STR05, that's a subbasin. So if I click on my Components tab in the Watershed Explorer, here it is, STR05. And let me go ahead and click on the results now and expand both simulation runs. STR05 is right here. And in the other simulation, STR05 is right here. So if I click on the graph here, this is for PRISM. This is the daily precipitation data. And here is the same subbasin using hourly precipitation data. You can just tell that the left plot here is using hourly precipitation data. And the peak flow is about 1,000 CFS higher, about 5,000 compared to 4,000. The PRISM data set here on the right, which is daily precipitation data, is a daily data set that HMS automatically converts to hourly values to match the HMS simulation time step. Representing the daily total precipitation and even hourly increment results in the incremental precipitation PRISM data rarely exceeding the constant loss rate, which means there's much more infiltration when the precipitation data is daily. On the other hand, when the precipitation data is hourly, there are many more time steps where that precipitation rate is significantly greater than the loss rate, resulting in much more runoff. The last plot that the exercise asks us to show you is the cumulative loss for the same subbasin for the two different simulations. So cumulative precipitation loss, and I'm going to hold down the control key and then scroll down. Here is the other cumulative precipitation loss. It's hard to see here in this little diagram, but I can click the graph button here and then expand. This right here is the next rad data, the hourly precipitation. And as you can see, there's more runoff, therefore there's far less losses. In the top plot here, this is the dashed cyan line. This represents our PRISM data with a lot more losses over the course of the simulation. Well, that's it for this exercise. We downloaded PRISM data and we imported it and then ran some simulations. Also, this exercise highlights the importance of selecting an appropriate data set for the watershed. In this case, the Cannon River watershed is relatively small, and using hourly precipitation data is beneficial and accurately captures the rainfall runoff response and losses.